Hello, Mrs. Dewey. This is John Beederwig. Today I'll be going over a problem dealing with limits. So first, we have a piecewise function of f of x is equal to negative x squared plus 4x plus 1 when x is less than 3, or 4 times 0.6 to the power of x minus 3 when x is greater than or equal to 3. The first question asks us to find the limit of x as x approaches 3. So what I did is I figured since 3 is greater than or equal to 3, I used 4 times 0.6 to the power of x minus 3. But I noticed that 3 minus 3 is 0, so anything to the power of 0 is equal to 1. So the limit as x approaches 3 is equal to 4. Next, it gives us the epsilon value of 0.5, which means that the upper and lower boundaries would be 4.5 and 3.5. Then finding the corresponding x values, the boundaries were then shaded in. When estimating for the x values, I got the x values to be around 2.7 and 3.3, meaning that the delta values would be around 0.3. Now to check graphically, I entered the intersection equations of y equals 3.5 and y equals 4.5. When finding the intersection between the graphs and the piecewise function, I got the x values to be 2.71 and 3.26. To find the delta values algebraically, I plugged in the 4.5 for the top equation since it is predicted that 2.71 would be the x value, which is less than 3, in which the delta value came out to be about 0.2929. Now, when finding the higher x value, I used 3.5 and the equation 4 times 0.6 to the power of x minus 3, in which I found the delta value to be about 0.2624. Finally, for the formal definition of limit, this equation would be as 4 is equal to the limit as x approaches 3, if and only if, for any positive number of epsilon, there is a positive number of delta such that if x is within 0.3 units of 3, but not exactly equal to 3, then f of 3 is within 0.5 units of 4.